Good morning, Amherst. Today's Wednesday, March 25th, 2020. I'm looking at our self-test for the solutions unit. I've just gone through it this morning. It's big, it's bad, it's gnarly, it's got a few things that need to be fixed. So what I'm going to do is I'm going to have this video out. I'm going to point out a few factors that you should consider beforehand, give you a few hints, a couple questions to not worry about. And I'm going to make an assignment in Google Classroom and have it due on Monday, but I want you to just check it in. I'm not going to have you fill in the answers. Just make sure that you hit submit. You go to the Google Classroom, go to this assignment, and submit it before Sunday at midnight or Monday morning, whenever I put the time on there. And if you submit it, you get the participation grade. How's that sound? Okay, 10 for 10 for just hitting submit, but do the work. So look at the front page. It's okay. Next page seems okay. There are a lot of questions on here, by the way. There's a lot of work in this unit. Next page, number 26. I know people have struggled with this one in the past. They give you the equation, and basically you've got one barium ion here, barium plus 2, one sulfate, -2 ion gives you one barium sulfate. And they're asking you about how many moles of barium sulfate can you get. Basically, it's a 1-to-1 ratio here. So you solve it for your moles of barium plus 2 ion, and that will give you the moles of barium sulfate. It's just kind of goofy. Throws a little stoich in there. And the answer turns out to be 0.01. Okay, look to the key later for how to go through that. Number 28, it's a little bit ambiguous. When they say you've got 100 grams of KNO3, consider that to be a large amount, lots of solute there. Okay, go back to the first lesson on this unit where we talked about saturated and unsaturated versus dilute and concentrated. Okay, that'll help you with that question. Next page. Number 39 is a goofy question. The attraction of water molecules to ions of a solute. It's actually called hydration, or hydrated ions. The process of breaking apart is called dissociation. It's already ionic, so they don't call it ionization, and neutralization is something from our next unit, but that's a silly question. So the answer to 39 is A. Next page looks okay. This chart is reminiscent of Table G. There are a few things that are maybe a little bit off. You have to get close, find the closest answer. It's multiple choice. Moving on to constructed response. Next page is okay. In number 53, please add a dot after 100. That'll keep your answer to 3 sig figs. You've got 3 sig figs here, 3 sig figs here. That needs to be 3 sig figs. Same thing in number 55. Make that 150 dot. Keep your 3 sig figs. In number 56 here, I'll give you a hint. They're asking about the ions of NH4 positive, and they give you a solution of ammonium phosphate. So if you were to write out a dissociation equation for ammonium phosphate, 1 NH4 3 times PO4, when it dissolves into water, is going to give you 3 NH4 positive ions and 1 PO4 negative 3 ion. So stoichiometrically, it's a 3-to-1 ratio. So if you solve it for the moles of NH4 3 times PO4, multiply it by 3. And then they said how many ions, so use Avogadro's number there. Multiply that times 6.02 times 10 to the 23rd. There's a lot of that in this worksheet. And final hint, in the last two questions, in 60 they give you sucrose. That is a non-electrolyte, has a Van Hoff factor of 1. In 61 they give you urea. That's also a non-electrolyte, has a Van Hoff factor of 1. Those should help. Okay, I will post this video up with a due date sometime around Monday morning, maybe Sunday at midnight. I don't know, we'll figure it out. But make sure you hit submit and get yourself a participation credit, 100% on that one. Talk soon. Ask me questions along the way.